Okay, many people have trouble calculating percent error, and part of the problem is that you didn't really learn how to do percents. So that's okay, we're going to figure it out. But percent error and percent uncertainty are not the same thing. Regular physics, you need to worry about percent error. Honors physics, you need to worry about both. So I'll tell you when regular physics can stop the video. Okay, so percent error is basically how far off you are from what you should have in an answer. Or like, let's say we're doing a lab. This is basically lab based. So this one here is more lab based, and it's about your results. So it's not about your measurements or anything like that. Percent uncertainty is more about your measurements. Percent error is about your actual results. So I'm trying to figure out what percent off am I. So let's say I'm going to give you nice easy numbers. So let's say I'm doing an experiment. I should have calculated my answer, my final result, as being 340 meters per second. But after doing the experiment and calculating all my results, I ended up with 330 meters per second. So I'm off, right? I have error. My error, just the actual error, is the difference between those numbers. So how far off am I? I'm 10 meters per second off. I'm like wrong. This is my theoretical. What I should have is my theoretical. And then what I actually got is my experimental. Okay, so don't get this mixed up with percent yield with chemistry. It's nothing like it. Okay, so what I should have gotten, and I'm off by 10 meters per second. Okay, so basically what we're trying to find out is what percent of what I should have gotten of 340 meters per second is my error, which is 10 meters per second. Okay, so what percent of 340 is 10? That's what you're looking for. So when you find a percent, think about your grade. Okay, if you were going to find out what percent of, let's make this smaller real quick. If I wanted to know what percent of 35 is 30. Okay? Basically, I'm trying to find my grade. There was 35 points possible on the test. That's what I should have gotten. I got 30%. Okay, so if I was going to try to find out what percent that is, I would just take 30 and divide by 35 and multiply by 100, and I would get my percent. So it's the same thing, right? So you're going to take the 10, which is your error. Okay, so that's my error, how far off I was. And divide by what I should have gotten. And then multiply that answer by 100. And that would be my percent error. So now I'm going to give you the actual equation. So the actual equation, theoretical minus experimental, and most of the time we just take an absolute value. We don't really care if this is positive or negative. The positive or negative just tells you, were you above it or below it? So whatever number you get, don't worry about that. But you're going to divide by your theoretical. So the theoretical minus experimental here, that is your error. And then you're going to divide by what you should have gotten. Okay, this equation here, I want you to put on your handy dandy equation sheet because you are going to use it a lot. So that one you want to put on your handy dandy equation sheet. Regular physics, you're done. You can stop the video now. Honors physics, you're going to go on for percent uncertainty. So here's a picture of two different rulers. okay? They're both centimeter rulers, but the top ruler, if we look at it, has graduations that go in between the centimeters, okay? So this one can go like 1.5 centimeters. This one can also do 1.5 centimeters, but if it's in between 1 and 1.5, we really have to, I don't know, is that 1.3? Is that 1.2? Whereas here, if we were looking at this one, we could really see that, hey, it's definitely 1.3 or 1.2, and we're trying to approximate in between the lines and trying to say, is it 1.25, 1.26? So the percent uncertainty has to do with your measuring device, okay? And it's how uncertain it is. So how off can your answers be? And the percent uncertainty will actually change with how big the thing you're going to measure is, and that's what we're going to see in our activity. But basically, it's a percent thing, okay? So let's say we were measuring this object. So if we were trying to measure this line, okay, we could just throw the ruler up and say, hey, it's 4 centimeters. And that would be the same on both rulers, okay? But this one, actually, I think I may have done it almost exactly 4 centimeters. But we can say plus or minus 0.05 centimeters because we know it's not 3.9. We know it's not 4.1. Do you see that? Okay, so it's not 3.9 because 3.9 would be right here, and it's definitely shorter than that. It's not 4.1 because it's definitely, or it's longer than 3.9. It's definitely shorter than 4.1. So 4, maybe a little bit more than 4 exactly. Okay, so yeah, we do want to be that precise. I'm sorry. So our uncertainty, because we can read between the lines, what we would say is our uncertainty. So you have to answer the question that's asked. Your uncertainty is how far off you are. Okay, how far are you not certain about your answer? And we would say we could be off by 0.05 centimeters. Okay, so your uncertainty is usually written as a plus or minus. So we could be 0.05 centimeters on the left side of 4, or we could be 0.05 centimeters on the right side of 4. But we know it's like somewhere right around. So we would actually give this measurement as 4.00, because we can go out to the hundredths place because we can read between the lines. Okay, this decimal place and this decimal place need to match. And this is our uncertainty. So this is how far off our measurement could be. If we, then what we do to find our percent error or our percent uncertainty is we want to know what percent of 4 is 0.05. So we take 0.05, we take our uncertainty and divide by our measurement, multiply it by 100, and that'll give us our percent uncertainty. How far, what percent are we uncertain? And you can see that as this measurement gets bigger and bigger and bigger, that this product, the whole product here, is going to get smaller and smaller and smaller. So the bigger thing that we can measure with the same measuring device, our percent uncertainty actually goes down. Equation-wise, our percent uncertainty, oops, I can spell. Our percent uncertainty is our uncertainty, so that's the plus or minus number. Don't forget that's the plus or minus number divided by our measurement. times 100. Okay, so what are you going to do if you're given the percent uncertainty and you want to know how far off your number is? So if we're given a percent uncertainty and we're told that there's a 2% uncertainty in a measurement of, let's say, 5 meters, what is the uncertainty? So we know percent uncertainty. So we know, here's what we know. Our measurement is 2% off of 5 meters. So basically what we're doing is finding 2% of 5 meters. Okay, so when you have a percent, you change it to a decimal and you multiply it, and that's going to give you how far off it is. So 0.02 times 5 is 0.1. So that means our measurement is off by 0.1 meters. It can be plus or minus 0.1 meters. This is our uncertainty. And so we would express our measurement as 5.00 meters plus or minus 0.01 meters. Okay, or sorry, not 0.01. Bad. Erase. No, not all that. .1 meters. 0.10 meters, because I told you your decimal places needed to match. So what that tells us is our measurement can be anywhere from 5 plus 0.1, so it can be anywhere from 5.10 meters to 5 minus 0.1 meters. So our measurement is somewhere between 5.1 and 4.9 meters. That would be the range. That's the range of possible measurements. Because we don't know that it's exactly 5 meters, because there's that 2% uncertainty, but we can say it's somewhere between 4.90 and 5.10 meters. So really, you need to pay attention. Are you looking for percent uncertainty, or are you looking for uncertainty? And it's all about percents, and it's not really your fault you don't understand percents, but you do have to figure it out. Percents is a basic skill that you're going to need to understand. So you're taking 2% of 5. That's your uncertainty, because it's a 2% uncertainty in the 5 meters. So hopefully that clarifies, and we will have more time to practice tomorrow. So we'll see you later.